Hey everybody. Well, guess what? Today we're going to be taking a look at plate tectonics. We've been looking at African geography, and this will put a little bit of closure to our African geography unit. Today we're going to do things a little bit differently. What I would like is for you to not do your do now in a separate question, but actually in the document I've attached. So if you go to the top of the document, it says here, remote learning, National Geographic colliding continents. Here you have National Geographic colliding continents, directions, answer all the questions, watching the screencast and the videos that are inside the Google slide. So here you have your do now. So take a moment to pause this video and answer the do now, which is look at the map of the world. What do you notice about the shapes of the continents? So take a moment and pause this video to answer that question. Excellent. So when you look at the world, that's where we're going to focus on today, is really looking at how the continents came to be. Why does this picture look like a chicken? Why does this one look like a cat playing with a ball of yarn? Well, we're going to try to answer all of that because for our objective today is for you to be able to identify how plate tectonic theory works. And by the end of class, you'll be able to answer questions on the plate tectonic theory. So on the same sheet, you answered the do now. Pause this video and take a moment to answer, what do you think the three layers of the Earth are? So what is this red dot? What is this yellow area? What is this orange area? What is this little thin brown area called? So if you were able to answer crust, mantle, core, you were correct. You have your inner core, your outer core, your mantle, and your crust. Actually, the mantle is this little orange part. So you have an inner core and an outer core, and your crust. We live on this little thin area called the crust. There are two types of crust. There's oceanic crust, and there's continental crust, and I'll explain more about that as we go through. Now, another question. Looking at this fence, why did it move? No, the owner did not build it wrong. He was not that stupid. So what happened? How could this fence possibly move? I mean, if you look at the ground, it's still perfectly fine. So how did it get all the way over here or all the way over here? What do you think? Again, this is a prediction question. So what do you think? So answer that question on the worksheet provided. You can pause the screencast while you go to answer that. Okay. So when you look at the Earth, I like to call this giant surfboards because each area of the Earth is actually riding on a giant surfboard. Now, why do I keep saying that? Because underneath the crust of the Earth, inside the mantle, is an area of liquid magma. When you look at this area, it's basically the ocean of the Earth, except it's magma, not water. And this area is designated this part because of it's always moving. The magma is constantly churning and moving, just like the oceans with currents. Oh, convection currents comes back, except it's in this form, it's in magma. And so the Earth can be broken up into several different plates. When you look at these plates, this idea was first developed by a scientist named Alfred Wegener. And Wegener came up with this theory in 1915. Now, even early explorers like Magellan, when they were making their maps, they realized that, wait a minute, South America used to fit into Africa, but why? They couldn't figure that out. Technically, where we are here in North America used to be part of Africa, right here. But why? Why did they move? And Wegener was a geologist, and he realized that rocks and fossil samples that matched here in Connecticut and part of the eastern seaboard matched those in northern Africa and Morocco. Similarly, here in South America and Brazil, it matched over here in this part of Africa. But why? They couldn't figure that out. And ultimately, Wegener's theory was dismissed. Scientists are like, no, it's just not right. It's not possible. And so it wasn't until 1950, even all the way up into the 1970s, that the plate tectonic theory was actually proven. That Wegener's theory back in 1915 was true. Now, when you look at the names of the plates, some of them are pretty standard. North American plate, that's where we are. Caribbean plate. Well, we just got done studying the Caribbean hurricanes, but if you look at this red line here, well, anytime a plate moves, this creates an earthquake. Or if it's an underwater earthquake, creates a tsunami. Back in 2008, Haiti had the earthquake. Well, Haiti's right on a plate boundary. You look at Japan over here. Same thing, Japan. Japan's actually on like one. It's on part of the North American plate. It's on the Eurasian plate. It's on the Pacific plate. And it's on the Philippine plate. So it's on 4 different plates. So when the earthquake struck Japan back in 2011, no, 2000, anyway, when the earthquake struck Japan, it created an underwater earthquake, which created a tsunami. So all of these things are interconnected in some way, shape, or form. But why are the continents always moving? Why are they always changing? So we know enough as to how they're going to move, where they're going to move, and we have a general idea of when exactly they're going to move. But when we're looking in terms of scientific research, it's hard to understand the whole premise of what it may look like in the future. Scientists have a general idea. On average, some of these plates only move maybe an inch a year. Some are less. Some are like 10 millimeters. Your fingernail grows more than these plates move. But when they move, they move. So when they move, there are 3 different ways that they can move. There's a divergent plate, a convergent plate, and a transform plate. This diagram does a pretty good showing you what they are on the bottom. But what I'd like you to do is now pause this screencast to go watch my video demonstration of how plate tectonics work. So hopefully you enjoyed my demonstration. What I would like you to do now is to go back into the video worksheet, and I would like you to answer questions on the video by National Geographic. So watch the video and answer these questions. So you have 32 questions based on the video that is provided here. So you can pause my screencast to watch this video. So now that you've seen how plate tectonics work and ultimately how it shaped our planet, let's take a look at what the future holds for the Earth. So this is the evolution of the Earth and how scientists believe it looked like in the past and what it will look like in the future. If you look at this rock right here, this is the middle of the United States. Here and down here is part of Africa. These two areas of the world actually have some of the oldest continental crust on the planet of the Earth. The Drakensberg Mountains down here in Africa, and part of the Rocky Mountains up here in the United States actually have some of the oldest rock formations in the world that has not been recycled due to subduction. So I just wanted to share that. Also, right here, this mountain chain is being created because of convergent boundaries between South America, Africa, and North America. This is the Appalachian Mountains. This is where we are, ladies and gentlemen. Here is Connecticut. Here we go. The creation of the Atlantic Ocean is starting right here. Here's the birth of the Atlantic Ocean. See, South America's breaking away. Oh, wait, look. India. Here's India. As that broke away, you're getting the creation of the Great Rift Valley in Africa. Here's Madagascar, broke off of part of India. There's India as it's slamming into Asia. It's creating the Himalayas. Oh, look, Africa's pushing up into Europe. Italy is technically part of Africa with the creation of the Alps. The Matterhorn, which is the highest point in the Alps, is actually the tip of Africa. So if you're Italian, I hate to say it, but you're actually part African. The last ice age, when early man walked over. So in 100 million years, obviously the plates are going to move, as you can see in this video right here. Africa will continue to push into Europe and close off the Mediterranean Sea, crushing in Italy, Greece, and all of the countries here. Great Rift Valley is going to break away. Global climate change obviously will create flooding, and the Amazon River Basin will no longer exist. The Mississippi River will no longer exist, and the Great Lakes will no longer exist. It will now be ocean. California will finally break away. Here's California as an island. So, as you can see, the world will always be evolving. So what I want you to do now is to answer that question. What are your thoughts on what the Earth will look like in the future? And then finally, work on your plate tectonic worksheet. So here I provided you with a worksheet on plate tectonic theory. Read this and answer these 10 questions to conclude your plate tectonic lesson. Now, I know some of you are probably like, why are you, Mrs. Given, doing the same thing? Well, guess what? It's part of African history, and Africa has some of the oldest continental crust on the planet. And since we're studying it, it's a perfect time to understand plate tectonics. So hopefully you enjoyed today's lesson. Next class, we will take a look at African kingdoms. Have a good one.